Okay, good day class. So today we will continue with 5.2.3, the parametric equation of a parabola. Alright, so last lesson we have discussed how to find the parametric equation for ellipse where we are using the trigonometry. Okay, so now we are going to parabola. Okay, so we know that the parabola, the standard form of a parabola is y squared equals 4ax. This standard form is for the vertex at 0, 0. Alright, so also can be defined by using the parametric equation. So let's say if we have two parametric equations, x equals at squared and y equals 2at. T is the parameter, can be any real number. Alright, then let's say we square both sides. Okay, so this is y. So y squared. So y squared is 4a squared t squared, right? And from here we know that actually at squared is x. Or at squared is x. So we factorize at squared. So one more a here, right? So 4a squared t squared I can write as 4a bracket at squared. And at squared is x. Right? So when I use these parametric equations, I can get back the Cartesian equation for the parabola, which is y squared equals 4ax. Therefore, we can say that the equation of locus of point P, alright, can be also written as this one. So this is the parametric equation for parabola. Right? X equals at squared and y equals 2at. This is for the vertex is at origin. Alright? So any point on the parabola will have this parametric coordinates at squared, 2at. So at different point, the t will take different values. Okay? So remember this is for origin, vertex origin. So how about if vertex is not at origin? Let's say at hk. Very simple. So at the parametric equation, the x become x minus h. So equals to at squared. Okay, so for y, so y minus k equals to 2at. Then you simplify it and get x and y. Alright, so this part is quite long and a little bit complicated. So never mind, we do it slowly. Okay, so for parabola, the parametric equation is in Cartesian form. Alright, but it actually can be expressed in trigonometry form like this also. Or like this, trigonometry form like this. Okay, also can. But we seldom use because it has some limited. Alright, so we will see one example in your textbook. Y for parabola, the trigonometry parametric equation is not that common. Alright, so we will look at textbook page 242. Please open your textbook page 242, example 5.25. Alright, this example. Okay, this example. So you see, find the Cartesian equation of the curve whose parametric equations are x equals cos 2 theta and y equals cos theta. This parametric equation is given in the trigonometry. So the solution, same we want to get Cartesian means we have to eliminate the theta. So x equals cos 2 theta, right? And cos 2 theta is 2 cos square theta minus 1. Why we use this one? Remember cos 2 theta has 3 different equations. Okay, why we choose this one? Because y is also cos theta. Then we submit because y is cos theta, so cos square means y square. Right, so now you eliminate the trigonometry cos. So x equals 2y square minus 1. Then minus 1 shift here become x plus 1. The 2 shift here, so half x plus 1. Y square equals half x plus 1. See? So also can, but not common. Why? Okay, let's look at this. Let's sketch the graph and show you. So you see that this graph sketch only from -1 to 1. See that? This graph only sketch from -1 to 1. Okay, why? So it's explained at the next page. Okay, here. It's explained at the next page. So this is the Cartesian equation of the curve, which is a parabola and opens to the right. Alright, since we know that for trigonometry, we have a range. So we know cos 2 theta, for cos, the maximum and minimum is -1 to 1. For all theta, right? So means that we know that cos 2 theta is our x ma. Alright, from here, then the parametric equation. Alright, x is cos 2 theta. See? Alright, since cos 2 theta lies between -1 and 1, so x also lies between -1 and 1. See? Therefore, the parametric equation represent only the arch PQR of the parabola. So this parametric equation, it means that this parametric equation represent this parabola from -1 to 1 only. So only this part. Out of this, no, it's not represented by this. Yes, this is why the parametric equation in trigo for parabola is not that common. Alright? So normally we will use Cartesian like this. Okay, this is quite often. Alright, so next we will see, we will discuss one question, okay, in checkpoint 5.6. Alright, so page 245. Alright, checkpoint 5.6, question 2. Sorry, question 3. So I hope you check. Okay, so this is question 3. See, just same like question 1 and 2 lah. Question 1 is for circle, question 2 is for ellipse. Alright, yeah. So now parabola is question 3 lah. So you see, given that the parametric equation below represent parabolas, so by finding the Cartesian equation of each parabola, determine the focus and the equation of the directrix. Also, you have to refer back to your notes, how to find focus and directrix for the parabola, then sketch the parabola. Alright, so you see that there are 6 questions here. Some they give you the Cartesian parametric equation, some they give you the trigo. I will discuss each one. So the rest will be your homework. Remember, the rest will be your homework. I'm going to discuss C and B. Alright, so the rest will be your homework. Okay. So record down, right? Record down, please drop down. Others will be your homework. Alright, okay. Let's look at this one. So checkpoint 5.6, question 3C. So question 3C is given to you the parametric equation x equals this one and y equals this one. Alright, okay. Why? To eliminate the parameter, actually we have different ways. It depends. You have to see what is given to you. Okay, so why I do x squared? It because I see t squared plus 1 over t squared. So I know that after I square this thing, so I will get the terms t squared plus 1 over t squared also. See that? So that the y can sub in. This is why I square x to eliminate the t. So I square both sides. So x squared, 2 after you square is 4. So this one also square. So first term square, second term square. So 2 multiply t and -1 over t, left -2. T and t simplified. Okay? Now this is y. This term is y. So become 4y minus 2. Alright? So when we see x squared and positive here, right? So we know that it's a parabola open upwards. Alright? So compared to the standard form, x squared is equals to 4ay, remember? So I write it in the standard form. So x squared equals to 4 is already here. So what is your a? There's nothing here, right? Means a is 1. Yes. And y is y minus 2. So when we see this thing, we know that the vertex is not at origin. Okay? Yeah. So the vertex is what? 0, 2. Okay? So the focus, because the question asks for focus, right? So because we know that the curve is open upwards like this, so we know that the vertex and the focus should lie on the same vertical line. So if same vertical line, x will be the same. See? And what happened to y? So for vertex, y is k plus a. This is k plus a. A is 1, 4ay ma. So 2 plus 1, 3. So this is your focus. Alright? Then next, directrix. The equation for directrix, so if it is open upwards, the directrix is horizontal. So if a horizontal line is y equals something. Alright, so if you still remember, so you can refer back to your notes, page 19. Okay, you can take out your notes and open to page 19. Let me see. Okay, here. See, page 19. this table. Yeah, how to find the, so you know where to get the vertex, how to find the focus, how to find the directrix. All right, so we are now here, number 3, third one. Okay, so just now you see focus is same, x same, so k plus a, and directrix is y equals k minus a. Refer back to this one. Okay, so k minus a, so k is 2 minus 1, so the directrix is y equals 1. All right. Okay, now the question want you to sketch sketch the curve. So for vertex is 0, 2, so here then just open upwards. Okay, if you want to mark down your focus also can. F3 here is 1, 2, 3 ma, and the directrix is y equals 1, so this line, this is your directrix. All right. Okay, so this is question 3C. All right, then we see one trigo, 3B. So you are given the parametric equation in trigo. So x equals cos 2 theta, y equals sin theta. All right, now cos 2 theta, remember we have 3 formula. So now I'm going to use this one, 1 minus 2 sine square theta. It's different than what we discussed in the textbook just now. Just now we used 2 cos square minus 1 because here is cos, but now here is sine. So from here you see that actually for parabola, the parametric equation in trigo is not standard. It's not fixed. Therefore we seldom use, but still can. So now cos 2 theta, I'm going to use 1 minus 2 sine square theta. And sine theta is y ma, so 1 minus 2y square. All right, so we rearrange in standard form. So 2y square, so it's 1 minus x. So the 2 shift here become like this. So I want to write the x first minus x plus 1. Then I factorize out the negative. So become x minus 1. All right, so we write it in the standard form. Remember standard form? So it become y square minus 4ax, right? This one remain. So what is your a? So minus 4ax. So must be 4 here. So 4 multiplied what? You get back now half. So 4 multiplied 1 over 8. After simplify, you get back your half. Okay? So from here, we get our a. Can you see it? Okay. All right. So from here, we get our a. A is equals to 1 over 8. All right? Okay. So next. So vertex. For this graph, vertex clear. X is 1, y is 0. So 1, 0. All right? So focus. This one, y square and negative. Y square, then negative. So we know that it's a parabola open to the right, like this. If open to the right, then we know that the vertex, the focus will lies on the same horizontal line. Means your y will be the same. Your y same. Yeah, so what happened to the x? So if you look at the formula at page 19, you will see that for the focus is h minus a. H minus a. So h is 1. So minus a is 1 over 8. Therefore, your focus is 7 over 8, 0. So this is the focus. All right, and the directrix. Okay, so the directrix, the formula is x equals a number. And this number is h plus a. So 1 plus 1 over 8, so 9 over 8. Okay? Yes. So these two are the info that the question one. Okay, now we sketch. All right, we sketch. So vertex is 1, 0 here. So this is your vertex. Open to the right, ma. And if open to the right, definitely it cuts the y-axis. So we sub x equals 0 in here. All right, so you find that y is plus minus square root 1 over 2. Plus minus square root 1 over 2. So it cut here. All right, it cuts here. So remember just now, in the textbook we say that because cos 2 theta is lies between -1 and 1, and cos 2 theta is x. So x also lies between -1 and 1. So we only sketch the graph from -1 to 1 only. So we submit x equals -1 here to find these two endpoints. So when you submit x equals -1 here, so you will find that y is equals to plus minus 1. Plus minus 1. So join here. Join here. Yes, this is a curve. Alright, so if you want to find the focus will be somewhere here. Which is less than 1, right? Okay, so directrix is x equals 9/8, so it's more than 1. It's here. Yes, this is the directrix. Alright, that's it. Okay, so remember, if you are given the parametric equation for the parabola in Cartesian form like this, then you can sketch whatever, because t is all real number ma. Alright, but if you are given the parametric equation of parabola in trigo, then when you sketch the graph, you have to be careful. We only sketch certain. So this parametric equation only represent the parabola from here to here only. Out of that, no, it's not. Okay? Alright, so this is question 3. So I discussed C and B. So remember, let me see, C and B. Never mind. Okay, so the rest you do as homework. Okay, so let's see some other example. So number 3. So find the loci of the following points. Loci means locus lah. Locus means the equation the equation of the locus. So you are given the parametric coordinates. So find the equation of this curve. Alright, so again, very simple. Okay, so I'm going to discuss A. So you are going to do B as your homework. So A, you are given these parametric coordinates. Alright, you can see So this is the parametric coordinates. So means x equals 2t squared and y equals 4t. Alright, so I rearrange this one. So t equals 4 shift here, y over 4. And then sub in here. T equals y over 4. So expand y squared over 16. So 2 and 16 can be simplified. So the 8 I can shift here. 8x. Therefore, you get the locus. It's a parabola. Y squared equals 8x. Only this. Okay? So remember, B you do as homework. Mark down. Okay. So we see one more. Question 4. For each of the following curves, obtain its parametric equation. Now they give you the curve, the Cartesian equation of the curve of the parabola. And they want you to find the parametric equation. Alright, so there are 3 questions here. So I'm going to discuss A and C. Alright, I'm going to discuss A and C. So you have to complete B as quiz. Alright? Okay? Alright, so question 4. A first, y squared equals 12x. Alright, so before we start, so remember, this is the Cartesian coordinates for parabola. X equals at squared, y equals 2at. Okay, this is for the parabola with the vertex at the origin. It's y squared equals 4ax. Also, this a is actually this a here. Okay, now we do. This one very simple. You are given y squared equals 12x. So find the parametric equation. Of course, in Cartesian now, we don't want the trigo. Alright, so the standard form is 4ax. So I write 12 as 4 times 3. Alright, so very clear, your a is 3. Alright, so just sub your a equals 3 into this 2 only. So x equals 3t squared, and y equals, a is 3, right? 2 times 3, 60. That's it. Simple, right? This is for vertex at the origin. Okay, we see one more question C. Y squared equals 6y plus x minus 5. So we see we have 2y. So we shift the y here. And next step, as you have done before, you know that we have to do completing the square. So y squared minus 6y. So we have extra 9 here. So minus out 9. Alright, so shift the 9 to this side, become x plus 4. Alright, then we write in the standard form. Y minus k squared equals 4a x minus h. 4a. But in front x plus 4, there is nothing, right? Actually, not nothing lah. It's actually got 1. Okay, 1. So to get 1 in terms of 4a, so I use 4 times 1 over 4 lah. Simplify, you get back your 1. But yes, we write it this way so that we know what is our a. Okay, now we find the xy coordinate. This is for, this one is for vertex at origin. Now vertex is not origin, right? Now the vertex is at x is -4, -4, 3. Or the vertex is -4, 3. Alright, so to find the parametric equation, you cannot just use this one. So very simple. Just that the left hand side x become x plus 4 lah. Okay, and this one same, at squared. So just now we say a is 1/4 ma, so 1/4 t squared. Alright, so for y also the same. Here is y minus 3. So sub in here, y is now y minus 3. Then 2at, so 2at. Okay, so remember lah, if the vertex is not at the origin, then you have to write like this. Or not just follow this one lah. Okay, then we just rearrange. So the 4 we shift here lah. So x equals 1/4 t squared minus 4. So minus 3 shift here become plus 3. Okay, so these are the parametric equation for this. Alright, okay. In that case, I think I want you to do 2 questions as quiz. Alright, please do 2 questions as quiz. So I want you to do quiz. This one quiz lah. This one is quiz. Another quiz is in your checkpoint 5.6. You can see? Okay, so in your checkpoint 5.6, okay, I want you to do question 3E. So your quiz will be 2 questions. This one and checkpoint 5.6, question 3E. Okay, I'll show you. Maybe some say that the textbook is not the same, right? 3E, this one. Alright, please complete these 2 questions as your quiz. And after that, direct upload to the Google Drive. Alright? So this video is just about 23 minutes. Alright? So plus 2 quiz. Let's say I give you 20 minutes lah, to complete 2 questions. Alright? So after you finish this quiz, so after 20 minutes, alright? So I will upload another video for the further one. The next one is actually this one. Okay, which is this one. Which is more complicated. That need more time. So this will be the second video. Okay, so please finish this quiz and finish these 2 questions and upload to the folder 8:30 plus about 40 minutes, 45 minutes. So by 9:15. By 9:15, you should upload your answer into the folder already. Okay, so 9:15, we will start another video. Alright, okay, thank you class.